Good morning. Am I audible?
Let's start with
We are the pioneers of the universe. We are the people who have the ability to dream and turn those dreams into reality. Quotes May Jameson. Assalamu alaikum and a very good morning to one and all. In the vast space of our universe, where science and traditions comes together so often, Chandrayaan-3 shines brightly as a symbol of India's astral hope and exploration. It shows India's strong determination to uncover the moon's mysteries. On August 23, 2023, Indian Space Research Organization scientists created history after successful landing of Chandrayaan-3 on the surface of the moon. Chandrayaan-3 is the third lunar exploration mission under ISRO's Chandrayaan program, marking India as the first country to land on the moon's south pole and the fourth country under the lunar exploration. The new historic feat has cemented India's status as a global superpower in space. In order to commemorate this historic saga, which has scripted a new chapter in India's space odyssey, and as per the invitation of the Ministry of Science and Technology and All India Council for Technical Education, AICTE, Ministry of Education of Government of India, PA College of Engineering is excited to host the Chandrayaan Mahotsav under the flagship of IEEE societies, namely Aerospace and Electronic Systems Society, Robotics and Automation Society, and Institution Innovation Council. On behalf of the PA fraternity, I welcome you all to this event. To begin this event, I now call upon Mr. Mohammad Shafi from the Department of Computer Science to invoke the blessings of the Almighty.
Good morning, everyone. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. يسبح لله ما في السماوات وما في الأرض الملك القدوس العزيز الحكيم. هو الذي بعث في الأميين رسولا منهم يتلو عليهم آياته ويزكيهم ويعلمهم الكتاب والحكمة وإن كانوا من قبل لفي ضلال مبين. وآخرين منهم لما يلحقوا بهم وهو العزيز الحكيم. صدق الله. Whatever is in the heavens and whatever is on the earth is exalting Allah, the sovereign, the pure, the exalted in might, the wise. It is he who has sent among the unlettered a messenger from themselves, reciting to them his verses, and purifying them and teaching them the book and wisdom, although they were before in clear error. And to the others of them who have not yet joined them, and he is exalted in might and the wise. Thank you.
Thank you, Shafiq. A warm welcome is the universal language of kindness. I now invite Mr. Ismail Shafi AM, Coordinator, Co-Scholastic Activities, BA College of Engineering, for the welcome speech.
Respected dignitaries, invitees, colleagues, and my dear students, good morning to all. And a warm welcome to this prestigious Chandrayaan Mahotsav. Today, we are honored to have Dr. S.A. Khan and Mr. Puneet Kumar Mishra, along with all our esteemed dignitaries joining us remotely. Chandrayaan missions have made substantial contributions to our understanding of the moon's geology, surface composition, and the presence of water molecules. These missions have not only showcased India's capabilities in lunar exploration, but have also enriched the global scientific knowledge about Earth's natural satellite. ISRO continues to plan future lunar missions to further explore and study the moon. I extend my heartfelt congratulations to all our dedicated scientists and co-workers for these remarkable achievements. I extend my heartfelt welcome to Dr. S.A. Khan, a distinguished former scientist from DRDO and a professor in the Department of Mechanical Engineering at IIUM Kuala Lumpur, Malaysia, for accepting our invitation to deliver the keynote address virtually. Welcome you, sir. A warm welcome also goes to Mr. Puneet Kumar Mishra, Head of the Satellite Antenna Characterization Test and Design Section, UR Rao Satellite Center, Bangalore, whose expertise is truly invaluable to us. Welcome you, sir. I extend a warm welcome to President for the day, Dr. Ramiz MK, Principal of BA College of Engineering. Welcome you, sir. I extend a heartfelt welcome to Vice Principal, Dr. Sharmila Kumari, Dean Student Affairs, Syed Amin Ahmad, for this program. It is my pleasure to welcome the heads of various departments, faculty members, teaching and non-teaching staff, as well as our dear students who have all contributed to making this event possible. Welcome you all. We are delighted to welcome the participants from various places who are tuning in our program via our YouTube channel. Your virtual presence is much appreciated. Once again, a warm and sincere welcome to each and every one of you who are present here or watching our program on YouTube. Your participation is essential for this remarkable event. Thank you.
Thank you, Shafi sir. A warm welcome to you too. Ladies and gentlemen, today we assemble with hearts brimming with pride and hope, united by a remarkable feat that transcends borders and kindles the human spirit. We gather here to celebrate the culmination of years of hard work, innovation, and unwavering dedication that has brought us to this momentous occasion. Chandrayaan-3 is not just a triumph for ISRO and its scientists, but a testament to the enduring power of human curiosity and perseverance. Now, I would like to welcome Dr. Ramiz MK, Principal, BA College of Engineering, to deliver the preamble for today's event.
Respected guests of today, Dr. Khan, Mr. Puneet Kumar Mishra, dignitaries present offline, those who are watching this program online, various principals of sister concerns, the students of sister concerns in PAT, the students of the PACE group, the schools in the Middle East of PACE groups, and also the students of various schools and colleges who have joined this program. A very warm welcome to all of you and congratulate you for joining this program. Before I start, I would like to introduce our guests to each other. Puneet Kumar Mishra sir, Dr. Khan sir was our former principal. He has actually worked with our former president APJ Abdul Kalam in the launch of various satellites. I think he may mention a few in his talk. And he was here in our PACE campus for 8 years. I think all the faculty members may not be the first years and second years. You may not know him, but all the faculty members, they know him very well. And whenever we have a program, whenever we invite him, always he's ready to join with us. Thank you, sir. Thank you very much. Puneet Kumar Mishra is another personality who has an association with PACE recently in the form of IEEE. He's the member of the board of governors of AESS. He's the one who is representing India and also the IEEE chair in Bangalore of the MTTS, etc. Puneet Kumar Mishra sir has recently visited PACE campus and he has motivated both the students and the staff members. And I was telling him, he came for inauguration of three societies of IEEE, maybe a 1 month back. Because of his visit, sir, we have started another 3 more societies and another 4 are in pipeline. That means we are having 10 societies. I don't know how many colleges are having 10 societies. So, but we are in the process. Thank you very much, sir. It was a great motivation for us for your presence. And thereafter, we had our Dr. Mohit, the Mangalore subsection chair, also to visit here. His visit was also a great inspiration for us. So I just wanted to introduce both of you to each other. The another few things I just mentioned about the preamble of this program. This is basically after the Chandrayaan launch. The AICT has taken initiative. So last week they have called the meetings with the principals and invited, that is to host the Chandrayaan Mahotsav with a lot of competitions and also some speakers from the DRDO, the space field to interact with the students. So initially, actually, the ISRO chairman, the present chairman, Dr. Somnath, he was my senior, the alumni of my alma mater of TKM College of Engineering. So we were trying to contact him, but today he's busy. So we are blessed to have another 2 distinguished personalities to join with us and to share their experiences with you. So it's a great proud moment for all of us. That is, we celebrate this Chandrayaan Mahotsav. So few takeaways we should, as students, we should take away. There are some takeaways from this Chandrayaan program. Number one is, you see, you fail many times. If you remember last time when Chandrayaan 2 failed, we all were sad. With a persistent effort, continuous effort, we are now able to be successful in Chandrayaan 3. I remember one talk is a very popular, a viral YouTube video of our APJ Abdul Kalam sir, the former president. So he told about in 1979, when the first satellite was launched, the whole country was looking at it and it was a failure. So at that time, the chairman of ISRO, he was the project director, our APJ Abdul Kalam sir. So Satish Dhawan, at that time, the chairman of ISRO, he told that, don't worry, I will go and address the media. So he went, he addressed the media and he told that our team has worked well, but they need more expertise. We will do it next time. So he was the leader and he took the responsibility of the failure. So after 1 year, after 1 year, when the launch was successful, so the project director at that time was still Dr. APJ Abdul Kalam. He asked Satish Dhawan to go and address the media. He told that, no, now you have successful, you go and address the media. So one message APJ Abdul Kalam gives in his talk is that the leaders are those people who take the responsibility of failures than responsibility of success. This time also I have seen Dr. Somnath. I was closely watching that interviews and also the live telecast during the Chandrayaan. So he spoke for one or few seconds, then he was introducing his team members one by one. So that is the quality of a leader. A leader always gives the fruits of success to his fellow beings. This is one message. Second thing from this thing is, since he was my senior, my alumni of my alma mater, TKM College of Engineering, when he resumed the charge of, chairman ISRO, he came to our college and he interacted. So few things he told, I think those messages should be taken by all the students who are present here. So he recollected the memories. He was a mechanical engineering. Actually, in this present Chandrayaan 3 team, we have around 16 people from our college in the development of the thing. So what he was talking is how his college, his alma mater has contributed, or you can take it other way. He was polite enough, humble enough to give the credit to the college, but basically it is his quality. So he told that we had one HOD, Mr. Albin, Professor Albin. So whenever we go, he used to find some mistakes and he used to tell us to be professional. So he told that at that time, when he had a project, it was a very good project, and good funding was also given by our college. So the project drawing was taken to the HOD. He looked at the drawing and he shouted at the students, including Dr. Somnath, is this the way an engineering drawing student draw this? So he says that whenever that you should be professional. He says that later, Dr. Somnath, he says that when he was in ISRO, whenever he does any plan for the projects, he remembers the shouting of his HOD. He took it positively, and he was doing it in a professional way, in a minute way. That is one message what he told. Second thing he told is that Professor Somnath, we had a teacher who taught drawing. You have this CAD nowadays, that engineering drawing. So now it is on computer. At that time, we had on a paper on the drawing board. So we use scale to measure 10 centimeter. But Dr. George, who taught us, actually, he was insisting us that when you draw a line 10 centimeter, you have now grid book so that you know what is 10 centimeter, but we have to draw on a plain book without any lines. So he was insisting us, when you draw a line of 10 centimeters, you should draw without a scale, because an engineer should have a sense to understand what is 10 centimeter by looking at the drawing. He was very particular on it. And second thing, if you want to measure 45 degrees, you're not supposed to use a protractor. You have to draw a line, 2 lines, and the inclination should be exactly 45 degrees. So Dr. Somnath says that kind of training, what I got during my engineering days, later when I joined ISRO, and I did thousands of drawings of rocket parts in the initial set, because he has not joined as a chairman, he has joined as a junior engineer who worked, who did a lot of drawing. So he says that these 2 messages, what I got from my engineering college, it helped me a lot. So today's program is basically, that is, we look forward at the audience today, maybe at school level, those who are at online in +2 level, or the students of our engineering college who are present here offline or online in their classrooms. We see a lot of ISRO scientists in this group. But one message what we should take is that these scientists and engineers are not built in one day. Just like Rome was not built in a day, it is basically a consistent and a persistent effort which starts from now and which starts with dreams. So I hope that today's program, with this preamble, with the interaction with 2 distinguished guests, will of course it will ignite some kind of fire, and I hope that it will take wings. And as our former president has told, it is wings of fire for us. So thank you very much. Wish you all the best.
Thank you, sir. Our esteemed guest for today's event is a highly skilled and experienced professional responsible for the crucial aspect of satellite technology, Mr. Puneet Kumar Mishra. Mr. Puneet Kumar Mishra has been a part of UR Rao Satellite Center, Bengaluru since 2004 and is presently heading its satellite antenna characterization, test and design section. Mr. Puneet Mishra has a rich experience of RF characterization of 48 satellites, 325 antennas and randoms. Mr. Mishra has also played a pivotal role in establishing satellite-level EMC facility and Asia's largest magnetic field measurement facility. Mr. Mishra has further conceptualized the world's first compact range with 10-meter quiet zone that is going to be commissioned in 2024. Mr. Puneet Mishra has published more than 60 technical papers in international conferences and IEEE transactions. Mr. Mishra has been a recipient of awards, namely IEEE IRSI Young Scientist Award in 2012, ISRO Young Scientist Award 2013, ASI ISRO Space Gold Medal in 2014, IEEE MGA Achievement Award in 2017. He is a senior member of IEEE Institute of Electronics and Telecommunication Engineers and Institution of Engineers, India, and also a life member of ASI. Presently, Mr. Puneet Mishra is serving as the Board of Governors of Global IEEE AESS, Vice Chair India Council, Chair IEEE MTT AP Bangalore Joint Chapter, and member of the Global Committees of IEEE Industry Management, IEEE APS, and IEEE Technical Program Integrity Committee. It is indeed an honor and privilege to have you, Mr. Mishra. Your expertise has left an indelible mark on the realm of space technology. Without further ado, I now request Mr. Puneet Kumar Mishra to address the attendees of today's event, followed by the inauguration of Chandrayaan Mahotsav at PA College of Engineering. Over to you, sir.
Thank you. Thank you very much for all your generous introduction. In fact, just 1 month before I was there, so that was not required because we know each other very well now. But thank you once again. And I'm really honored to be part of this Chandrayaan Mahotsav. And the credit goes to your principal, Saab, who has invited me again to this PA College of Engineering. So, dear friends, Honorable Principal and Vice Principal, HODs, students, and the keynote speaker and the past principal of PA College of Engineering. I'm really delighted and honored to be here virtually, in fact, among all of you in this Chandrayaan Mahotsav, which is a truly a scientific saga, I can say, and validates the Indian prowess in science and technology, especially in space technology, when we truly soft landed. Actually, it is not a soft landing. We can tell that it is like a feather landing. It was just like you are putting your leg on Earth. That kind of landing was there, because you might have seen during the launch, during the power descent phase, we stopped at 2 locations at 800 meters when the module was hovering for 10 seconds, and again at 150 meters when again it was hovering for 10 seconds. So you might have seen how slow it was landed. So first time in the Chandrayaan 2, we could not succeed. It was called as a crash landing or harsh landing. So we learned from that, and this time we have designed our systems and processes such that as and when we want, we can stop and we can really look towards the site where we can land safely. So as your principal told, that it is a really engineering marvel under the leadership of our chairman, Sri S. Somanath, who has rightly said that as an engineer, we should have some ingenuity, we should have engineering sense to design that. To begin with, I would like to tell each one of you, you may be thinking that you are from PA College of Engineering, you are not in Bangalore. In fact, you are in Mangalore, and that too at the outskirts of Mangalore, and you are not having the resources. So I would like to tell that don't believe all these things that you are not having resources, so you cannot do the things. And Chandrayaan 2 and 3 missions, in fact, Chandrayaan 1 onwards, all the missions are proving that. You may be knowing that India don't have capability to launch satellites such that they can directly reach to the moon orbit. You might have seen that India launched 1 month before, in fact, 40 days before to reach to the moon, whereas Russia launched just 10 days before and they were supposed to land 1 day ahead of us. It means their launch vehicles are much more powerful, they are much more resourceful, and they can land much easier. But still, despite not having those technologies, that much power launch vehicle, we tried. We used our engineering sense. We used our ingenuity to derive a path, a process, a procedure such that even though we are not having the capabilities, but we can reach to the pinnacle. So students, same thing I want to convey you. If you really want to do it anything, it is not the resources, it is your intellect, it is your ingenuity, it is your perseverance, it is your enthusiasm and passion which takes you to that location rather than the resources and all other things. They are required, but they are the stepping stones. They are not the final destination. Final destination is under your mental guidance, which you want to achieve, and you can achieve that. Second message I wanted to give you that we have chosen to land on the south pole of the moon. Why? Because nobody has reached there. And because of doing so, when we landed there, we found out several new scientific insights of the moon. People till now they were thinking that there are lunar regolith all across, and when we will land, there will be lot of dust particle which will be creating problem for us, and we cannot come out and open our uh, we cannot deploy our door such that our lander rover Pragyan can come out. We thought that we have to wait for minimum 4 hours. But when we landed on the South Pole, we found that there was not much dust. In fact, within half an hour, we were able to open that. But despite that, we waited for that much time. But when we came out and Pragyan took the photos, similarly, the lander took the photos, we understood that the lunar regolith is much lesser on the South Pole. Second invention, what we could do, our finding we could do there is a finding of sulfur. Chandrayaan 1 and 2 gave a lot of information about water on moon. So that proves that there can be a life on moon. But sulfur is most important because most of the nations, they want to use moon as a launch station to go towards the interplanetary missions. And sulfur is one such element which is used for launch vehicle propulsion system. So finding of sulfur also gives you a very positive indication that yes, on the moon, we can create launch vehicle and satellite propulsion systems, and that can be used, and definitely moon can be used as a launch site for further deep interplanetary missions. These are the findings. Another third important finding is the temperature variation from the surface to the deep inside of the moon surface. Our instruments have told us that on the lunar surface, temperature is as high as 60 degrees centigrade, at some places even 70 degrees centigrade. But the moment we are going 20 centimeter down, temperature is reducing to minus 10 degrees centigrade. It means there is a temperature gradient of 70 to 80 degrees, and this is sufficient to generate electricity. So these are the very positive outcomes of this mission, which shows that if we want in near future, definitely we can colonize the moon. And it may so happen that India may be the first country to have our own habitat on the moon, because we are so confident now that we can reach moon easily. We can land there, and in fact we can come back also with the development of the re-entry technologies what we are having. So these are the achievements of the students like you who have not graduated in a very high profile institutions. As your principal have already told that even Chairman ISRO is not from a tier 1 institution. Yes, he has done his MS and PhD degrees from ISC and other Institute of Eminence, but his BTech degree was from a state engineering college. So again and again, I'm telling you, don't estimate you. Learn as much as possible. Utilize your intellect, ingenuity, and passion to achieve greater heights. I think if you follow this, then as PM Modi told that now it is Chandrayaan, Chandrama is a tour. We can go on a tour and we can come back. Same way, I see that in next 25 years and next 30 years, it is not only moon, Mars, Venus, and all other planets. India will have its own footprints. And you people, younger generation people like you who are graduating now, they will be driving, they will be behind this force. And I'm pretty sure that our future is very, very bright. I think it is really Utsav time. That's why this Chandrayaan Utsav is being conducted across India. And I'm very happy to be part of this and wish you all success for your journey in this fascinating worlds of space technology. Once again, thank you very much.
Thank you, sir, for your anecdotes and insights on having an unlimited passion rather than counting on the limited resources to reach the pinnacle of success. Also, your messages on the positive findings of the moon, the humble beginnings of your academics to our students will not stop them from reaching the final destination. Thank you, sir. Now, we can have an interactive session with our esteemed guest. The audience online and offline can post any questions if required. Can we have some questions, please? Online audience.
Sir, I have a question, Puneet sir. Can you hear me?
Yeah, please.
So when can we expect India to send people to the moon?
Yeah, so a very good question. So you may be knowing that already we are working on Gaganyaan, which is the mission where first we are trying to send Indian people from Indian launch vehicle, from the Indian launch pad, using Indian technologies to the space. And towards that first unmanned flight will be happening this year itself. And I think within next 3 to 4 years, we will be having an Indian in space. And subsequently, I see maybe in next 1 decade, we will be able to send an Indian on moon. So this is the timeline I can see as for present technologies.
Yes, sir. Can you hear me?
Yes.
Even ISRO is doing the solar exploration, right?
Yeah, any message on that, sir? Any exploration?
Yeah, so actually this Chandrayaan 3 is also a part of solar exploration. Similarly, the Mars Orbiter mission, we are now working on Mars Orbiter mission 2, and we are going to have additional mission on the moon, Venus, which is called Chandrayaan, and beyond. So there are several explorations are planned, including an Indian space station. So proposal is already under consideration. And so these are the fascinating opportunities available for Indians to work on that. I think the expression of opportunity is already being out for the Venus mission, and a few of the engineering colleges and organizations, they have already submitted the proposal what should be the payload on the Venus mission. So I think with this success, we'll be working more and more towards space exploration, and most of the matured technologies in the form of communication, navigation, remote sensing satellites will be handed over to the private entities, and ISRO will be focusing more on scientific and space explorations mission. So you'll be seeing a lot of these activities in near future.
Sir, I found out that when we go to the moon, what about our breathing level, oxygen, how we get oxygen? Can we live there forever?
Pardon me, I'm not able to hear. Somebody can from the stage or dais can repeat the question.
Sir, am I audible, sir? Sir,
Yes.
about the possibility of existence of oxygen so that one can live in the moon indefinitely. How much
Yeah,
possible?
so that is another very good question. So that's what oxygen and water, they are very much essential for any human habitat. So once there is a finding of water, it means water is H2O. So there is a quite possibility of oxygen ions, as well as even if they are not there, we can disintegrate the water and we can create oxygen. So those are the plants which are planned for the habitation at moon. But water is most essential, which is available. So hopefully we'll be able to develop the most. It is not oxygen actually for the moon what is creating problem. The problem is there is no atmosphere. There is, you may be knowing, on Earth there is a radiation shield available, electromagnetic radiation shield available, which protects us from the harm fields coming from the sun, which is not available on the moon. So this is the most important reason why, rather than moon, people are thinking about habitation at Mars, because the Van Allen radiation belt and the radiation belt cover is available at those places, which is not available on the moon. So I think we have to engineer those protection system to have habitation, but it is required if we want to use moon as a launch base.
Thank you, sir, for answering the questions posed by our audience diligently. Moving further
Thank
on.
you. Thank you very much.
Today, we are truly privileged to have among us a distinguished guest who has marked a significant role in the field of defense technology. It is with great pleasure and profound respect that I introduce to you Dr. S.A. Khan, a renowned professor at Department of Mechanical Engineering, International Islamic University, Malaysia, Kuala Lumpur, Malaysia, and a former scientist at Defense Research and Development Organization. Dr. Sher Afghan Khan received his MTech from IIT Kanpur and thereon started his professional journey as a senior scientific professor at the Armament Research and Development Division, Defense Research and Development Organization, Ministry of Defense, India, where he served from 1984 to 1993. During this time, Dr. Khan was actively involved in the design and development of missiles, unguided rockets, shells, and bombs. Dr. Khan has also worked with the former President of India, Dr. APJ Abdul Kalam, who was the then Director of General Research and Development. In 1993, Dr. Khan assumed the role of an associate professor in the Department of Mechanical Engineering at Aligarh Muslim University and was subsequently promoted to the post of a professor in 2001. During his tenure, from 2004 to 2014, he took on significant leadership roles, serving as the principal and dean of research at PA College of Engineering and Barry's Institute of Technology, Mangalore. His contribution extended to ZH College of Engineering and Technology, where he held the position of principal from September 2014 to May 2015. Throughout his illustrious career, he has made substantial impact on the academia, mentoring 4 PhD students, and currently 5 students are under his guidance. His valuable insights and research findings have been disseminated through numerous research articles published in both national and international journals. In Dr. S.A. Khan, we find not just a scholar and a scientist, but also a visionary whose work transcends boundaries. Ladies and gentlemen, let's now hear it from Dr. S.A. Khan with the keynote address for today's event. Over to you, Khan, sir.
Can you hear me? Hello, can you hear me?
Yes, sir. Yes, sir.
Yeah, okay. 1 minute. Is it visible? This file is visible? Can you see this?
So it's visible, sir.
Yeah. Good morning. Today's guest, Mr. Puneet Kumar Mishra, Principal of PA College of Engineering, Vice Principal Dr. Shamila Kumari, various HODs, faculty members, students, and many audience online and offline. At the outset, I would like to thank the PA College of Engineering for giving me this opportunity to be a part of this. So quickly, I will just tell you what contribution I did being in the DRDO from 84 to 93. So these are the different mortar bombs. The mortar bombs are being used when you want to attack enemy behind the hill, because the gun you cannot angle of elevation cannot go more than 50 degrees. But the mortar bombs, it is vertically launched at 90 degrees, you can launch it. And this is being used to destroy the enemy hiding behind the hills. So after my joining, so we took up all these weapon systems, 51 mm mortar bomb, 81 mm mortar bomb, and 120 mortar bomb. And I did not add any extra weight for my troops to carry. Without adding any extra penalty on the weight of the weapon system, we are able to increase their ranges. That was one of the biggest achievements during my stay. And then the artillery gun, which is being used during the wartime by the artillery gun. So here, what we did, we know that the total drag, which is skid friction drag, wave drag, and base drag. So during the transonic zone, the base drag is very, very high, which is around nearly 2/3 of the total drag. So that is why what we did, we used the base bleed technique. So whenever in the trajectory, when it is in the transonic zone, we use this base bleed technique and we are able to increase the range by 240 kilometers. I also worked on this HSLD bomb, that is high speed low drag bombs, which is being delivered. Their weights is 250, 500, and fuel air explosive bomb, special purpose bomb, and this is the RP bomb, that is being used to destroy the runway so that enemy cannot launch any aircraft. And similarly, we have done the simulation of the trajectory when released from the fighter planes, because it's a very, very critical stage, should not hit our own aircraft. So this we have contributed. And then for the army, the 120 mm Grad rocket, which is being given by the Russian. From Russia, we have purchased this. And then what we did to train our troops, this range is not available so easily. So what we have to do, you just add on some square rings in the nose part of the rocket, so that because of the high drag, this range will come down and we can train our troops for the range and accuracy practice. Because if you want to redesign the rocket, it is not that easy, because you have to do so many things. So best thing was, since it was available in bulk, so simply we just fabricated a ring and then put on in the nose portion, and then we are able to reduce the range, and then we are able to train this. And then this is the Pinaka rocket, which is normally MBRS in the international community call it multi-barrel rocket system, and it has got a wraparound fin, and the maximum range for all the unguided rockets which is available in the market, they are having around 30-kilometer range. But during my stay, I was able to increase the range to 40 kilometers, and our accuracy was better. And the circular CEP, we call it circular error probability, it was around 1%. And then similarly, we have got 68 mm rocket for Air Force. And then this is a very special weapon system design that is called dinghy. So initially, when it is loaded on the aircraft, it will be like a bomb. And once, whenever we are just searching for our sailors, whether they are there in the sea, so once we see our people, immediately we drop this, and then after dropping, because of the impact fuse will act, and then this will become like a boat. And in that boat, around 10 people can sit, and then for their food, medicine, everything is available. This is another weapon system we have designed. And then these are tank ammunition. This is the Russian tanks, T-72, T-92, and then MBT. This is the main battle tank, which is the Arjun tank, which is being developed, CBRD, Chennai. And this is the 120 mm ammunition we have redesigned for the training of the troops, so that in a shorter range they can be trained, so that we have used the concept of the choking of the nozzles. And then basically I was appointed by Dr. APJ Abdul Kalam for this project actually in 1983. So this was Agni project, Akash, Nag, Trishul, and Prithvi. So I would like to share with you a major concern. What we had is in the Agni missile, the aerodynamic heating is the major concern. And we all know that T0 by T is equal to 1 plus gamma minus 1 by 2 m square. So when you have Mach number 3, this aerodynamic heating is not a major issue. But when you have Mach 10 or more than that, then aerodynamic heating is a major issue. And in way back 1987, 88, no country was ready to give us any technology. And we have developed our own material by DMRL Hyderabad. And the advantage of having our own material is that you can use it wherever you want. If suppose you buy from US or any country, they will ask you where you are going to use it. They will observe you what you are doing with this material. But since we have developed our own material, right? So we are using this for our polio patient in the hospital. Whatever their calipers they used to make, the weight of that polio, that instrument used to be around 4 to 5 kg. But using this high carbon material, we are able to reduce the weight to around 400 grams. So you can imagine a child suffering from polio, and he has to carry this 5 kgs that system. So that's why we have used this to reduce that. And then another new thing is then we have used it for Prithvi missile, the bomblets, and then we have stabilized with ribbons. Because if you have to stabilize with the fin, then it will add the weight. Then also the volumetric efficiency also will get reduced. That's why we have used this. And because of this, my contribution to this is the commendation certificate was issued in 1989 by at that time the scientific advisor to Dr. Arunachalam, Ministry of Defense. Now I will just share a few of this. Mr. Shafi, you tell me how much time I have, so accordingly I will plan. Shafi? Mr. Shafi? Anybody is there? Tell me how much time you have. Hello. So now this I want to just share.
15 minutes.
How much?
15 minutes.
15. Okay. Okay. Now just I want to share with you this. 1 minute. This is the concept of the microjet because I was having the concept of the base plate for the 130 mm artillery shell. So once I went for PhD at IIT Kanpur, I already conceptualized this, how it can be done. And then that's why I just myself designed the nozzles. And then I discussed with my supervisor, then I will be using the microjets. Okay. So here the settling chamber. From here, I can get the, this is the settling chamber where the stagnation pressure is there. And because normally whenever using any active control, they will ask you whether from here you will get the energy. So I told them that I will be using my settling chamber pressure for the blowing and suction. So what we did, we just drawn the air from here and then you just blown it here. So and this blowing was done at sonic Mach number because it is just an orifice. And because of that, we are able to control this base pressure. And this is the concept for the first time is given by me to the scientific community. So this is the my contribution for the science and technology. And then this is the, now you can see this, you can see this shock wave. It is for under expanded nozzle, and this is the expansion fan, and this is the barrel shock, and this is the damage shock. So whenever the jet is being set to the free jet, then within 2-3 shock waves, it will disappear because it cannot remain and cannot maintain its identity in the atmosphere because the atmosphere is very big. Similarly, this is another thing, that concept of the the concept of the base bleed. Base bleed we have given, that is breathing blunt nose. That is, if suppose you have this type of a blunt base at a very high speed, then what we do, instead of having a blunt base, because there will be a oblique shock, both shock wave will be there and will result in a very high pressure. So what we suggested, that you can have a nose breathing. That means in the nose, you make the hole through into hole and then also passing through the base. So what is the advantage? This will result in the reduction in the positive pressure at the nose and increases the low pressure at the base. This is the advantage of the breathing nose. And then we have our group is well known in the high speed jets, and these are the various passive control technique to use to notches, the taps and multiple jets. And I am to share with you that my guru, my supervisor, because of his name, because earlier this tab was used by NASA group, and they said that this height of this tab should be less than the boundary layer thickness. So we have proved them wrong. Now you can go beyond that, and that is why this after this this paper appeared in AIAA journal in 2010, and then this new name is known as artificial limit. And then one of my student, PhD student, I think you know her, Dr. Asha Krasta. So along with her, she has developed the unified supersonic hypersonic similitude to stably derivate in pitch and roll. And then I have compared my method, my results with a very simple way what Hui et al. They did in 1982, and their method was very complicated, whereas I have used a simple, superimposition of half sine wave or full sine wave, and then varying its amplitude. We are able to match the, they have taken z is equal to bx to the power n. So for all the cases, sine wave cannot be matched. That's why we have taken only 3 values. That is n is equal to 1, n is equal to 0.5, and then n is equal to 2. And then we have compared those results. Okay, now these are some of the results we have compared with the Hui et al. As well as our own results, and it is giving results in a very reasonable limit. And the last one, now we are working in this area, the application of the fuzzy logic in the fluid flow. I think PA College electronics department can help us, just to or computer science department, how to use the fuzzy logics in the fluid flow problems. So these are the, I have talked about the, science and technology. Now this last slide, I will just take sometime. No. Now I'll take the next one. Can you see this? Can you see this slide? Can you see this? Hello? Can you see this?
Yes, sir. It's visible.
Just I want to show you this just one, one slide only. After that, I will take the other PPT. Here I want to show you that when you want to study the fluid mechanics, one is analytical method, another is the experimental method, another is the flow visualization, and other is the CFD. So I want to show you the beauty of this flow visualization. See, we have measured, experimentally we have measured the P naught, the total stagnation pressure on the P naught, which is the pressure given to the settling chamber, and this is the heater tube stagnation pressure. And after measuring that, we have plotted this. Okay. And after that, we have taken the shadow graph, flow visualization. Now from this data, you can see from this data, you can see that when this ends here, at the same time in the shadow graph also we are having the same line. Now this is actually work of our, your former PA faculty, Dr. Muhammad Fahim. It is the Fahim who did this work. Okay, so now you can see this. This is the, pressure is decreasing, flow is expanding, that's why it is decreasing, and then immediately there is a oblique shock, that's why pressure is decreasing. So whenever you measure experimentally, you measure this pressure ratio, you plot it, and then draw the shadow graph, take the shadow graph, and then how exactly they are matching. So this is the beauty of flow visualization. Okay, so now just since we are, in the talking about the Chandrayaan mission, so now just I want to share with you some of those things, because this as far as the history of the ISRO is concerned, you know that we started in 1962, and the launch vehicle, first time the launch vehicle was, under leadership of Dr. APJ Abdul Kalam, and then after that, other people have taken over. But for the very high speed flow, actually, what you need to do is you have to do the combustion and fuel injection and injection of the air at a supersonic speed. That is the requirement. So what when I was doing my PhD, we have taken up this work. This was from ISRO. So now you can see this. My job was to isolate the shock wave. The shock wave, it should be free from the shock wave, so that, because you know very well, whenever the shock wave formation, the flow will get decelerated. And if normal shock wave is there, its flow will become from supersonic to subsonic, right? So now just quickly, I will share with you this slide because time is short. Now these are the nozzle different views, and you can see the experimental setup. Okay, so now this is the this is the nozzle, and this is the isolator part. Okay, this is the only the lookup window, and this is the glass is there, so we can see the how the shock waves are being formed. Okay, so once nozzle is being fabricated, then we do the calibration, and that's why this is the calibration was done. Okay, what is the design Mach number and what is the actual Mach number available at the exit of the nozzle. Okay, now you can see when we have done for NPR 7. Now I hope you can see these diamond shock waves. Shafi, can you see these shock waves? Shafi, hi brother, can you see the shock waves? Hello? Is it visible? Right? Is it visible? Now my job is to remove these shock waves. This is my job. This is the job was given by my supervisor in 1998. Okay. Now you can see how I have done it. Now when when it is there, then you can see the wall pressure. You can see the fluctuation up and down, and it is moving, right? And then you can see another case, NPR 6, and this is the wall pressure. Now can you see the difference between these two and this, the third one? Is there any difference? Can you see this?
Yes, sir.
You see here you have got two full diamond shock wave and half diamond shock wave, right?
Yes, sir.
Now you can see in the third, am I able to eliminate the shock waves or not?
Yes, yes.
Okay. Now that this was my job, how to make it shock free. That's what is my job, and that's what I have done. And this was, to achieve very high speed, hypersonic missile, hypersonic, launch vehicle and all that. Okay. Now can you see this NPR 6? This one is having the shock wave inside the duct, whereas this is completely free from the shock wave. You agree?
Yes, yes, sir.
Okay. So this is what exactly we have done in 1998. Okay, now you can see the pressure distribution, wall pressure distribution. When the shock waves are there, this fluctuation you can see. When the shock waves are not there, and this is a very, very, smooth pressure distribution. Now we can see another case when NPR 7, where we have reduced the length. So can you see these shock waves which are there in this, right? And then in the last one, it is totally free from the shock wave. Okay, and this is the pressure distribution of the wall, and similarly, this is the another case when NPR 6, and this is the diamond shock wave for these two cases, and here it is totally free. Okay, so similarly for NPR 7 and the smaller length of this duct, you can see the presence of the waves, and here very little is gone, but in the next one you can see that it is totally eliminated. You can see here totally I am able to remove or eliminate the shock wave. So either you have to swallow the shock wave, or you have to just throw it away outside. And this portion is known as isolator. I mean, it will isolate the shock. Okay, so this is what actually I wanted to show, and because the time was limited, so I did not take any other thing. And if you have got any doubt, anything, you can ask me. I have many things to show, but I was given limited time. That's why I just hurry up the things. And I want to tell you that, when you have the technology, you can use it whenever you want. See, for example, for the DRDO, we have used all the, ISRO technology. The propellant which is being used for the Agni missile, it is from ISRO only. That we have got the technology because it is our own technology. We can use wherever you want. So for the this launch vehicle, core jet has Mark 3, and other strap-ons were there 2.5 Mark. And acoustic load is the major issue whenever it is being launched at the liftoff. When the jet is impinging on the launching pad, and that have acoustic load is very, very high. So this study also we have done at IIT Kanpur for the PSLV, GSLV, water launch vehicle. Okay, any questions?
Thank you, sir, for providing an elaborate information on the missiles, bombs, unguided bombs that you have done, and also your immense contribution to science and technology. Also, the illustration on isolation of shock waves also was very informative, sir. I request the audience, if any, can pose a question to our to S.A. Khan, sir. Anybody from the audience?
So our students are mainly from first year and second year here offline. So to what extent I think our students have understood the technical part of it. But one thing I would like to tell our students is this program, where in the first part actually it was kind of a motivational type, where some general information has been given, and what Khan sir has told is basically the technical part. So after motivation, the second thing is that you have to take some steps. So certain things which we may not understand, but these are the areas where we can contribute. Especially nowadays, as we repeatedly tell, there is no boundaries, no clear-cut boundaries between the branches. So all the branches of science. Sir has told about some physiologic implications in the from the electronic side. So the students who are present here, the first year, the second year, and the students who are online, maybe 10th standard, 11th standard, 12th standard students, you can have your dream that I will be one among them. Because you see, on front face, we see a lot of people from ISRO. The chairman is there, the scientists are there. But as per the chairman itself, hundreds of people have worked behind it. So he was telling about that is one nozzle. It is taken to a workshop. The person who works on the nozzle, on the legs, he has also got a contribution. So what we can dream is what possible level if we can be a part of for the future. So that is going to be a great thing. So Khansa's technical presentation, what has been done now, whether we have understood or not, basically the message what we will take now is we should be a part of it. But still, I think if anybody has got any kind of a technical question or any kind of a generic thing to this, you can ask.
I want to tell you that, your alumni, Ambreen Khan, just today she has defended her thesis, and she has worked being from computer science, BTech computer science. She has done MTech and PhD in aerospace engineering, and there she has used machine learning, ANN, DNN, CNN, all these techniques on the experimental data she has used. And this is the, and then she has done the CFD.
This is another area the students can work on. That is basically the application of AML, artificial intelligence and machine learning. So in the data, I think is it possible for the students to get data for any kind of?
No problem, no problem. Some faculty should come forward to take the ownership.
Okay. So now this university has previously university did not allow us to do projects across the branches. Now university has given the permission that projects team can comprise mechanical, civil, electrical, electronics, any branch can come together and do the final year projects. That is one university that they are now encouraging interdisciplinary projects.
Okay, okay.
Any questions, students or faculties? Anybody can pose some questions. Thank you.
You
sir.
ask anything, any very simple question. Maybe it may not be very. You should speak up, Baba. You don't have anybody from mechanical?
Sir is ready for any questions, students.
Any mechanical, any faculty?
Students
Mechanical
have-
faculty is not there.
Yeah, you can ask. So I guess there is no questions.
Hello, sir. Can you hear me, sir?
Yeah, tell me.
You have actually, I was really happy to see you have worked on various technologies involving the defense DRDO projects and so on. So have you had any experience to work on the current technology where most of the countries, the developed countries are working on ICBMs, intercontinental ballistic missiles and so on? Is there anything that you'd like to share?
Actually, I am not a man of propulsion or combustion. Actually, my is aerodynamics, high speed aerodynamics, hypersonic flow. So I think you have to, because it is not one man's job. My area is aerodynamics, high speed flows. So there I can contribute, I can help you, but not in the propulsion.
Okay.
The propulsion area.
Okay.
So you have to look for some. You see here in DRDO we have got around 45 labs. DRDO, 45 labs, and every lab has got around 1,000 scientists. So 40, you just imagine 45,000 scientists are working for these projects. So one person cannot do all that. Are you getting me? So propulsion itself is a big task. We are working on, shape optimization of the missiles. You might have seen that normally ogive shape is being formed for the missiles, or even ogive shape for the nose of the fuselage of the aircraft. So how to optimize this, how to get best out of it. So all those things, that is my area. And then we are using this now, this soft skill, what Dr. Sharmila Kumari and Computer Science Department can help us. The artificial neural network, ANN, CNN, DNN. So all these things it can be clubbed together to show that.
Hi, sir.
Yes, yes. Tell me.
Sana,
Tell me.
the Chandrayaan took 41 days to reach the moon.
What that?
Sir, she's asking why did the Chandrayaan take 41 days to reach the moon? Such a long span of time to reach the moon.
So that is the technology we have. We have to improve the technology. Simple. Suppose somebody from Bombay to Delhi, by train you reach around, by flight you reach in 2 hours. By train you reach for 24 hours. By Rajdhani you reach in 17 hours. So it depends upon your speed.
Yes. Puneet, Mishra.
Actually, this question was addressed by Puneet Mishra in the beginning. A Russian vehicle which was launched, it was supposed to reach one day before, within 10 days. So what he told is that we Indians, we have worked with a technology, what we are having, but still we were able to reach. So we expect you people to design a vehicle which can reach in less time. So that means we have a lot of scope for improving the technology.
Yeah, but Dr. Ramesh, I want to tell you, it is, finally it looks very simple, but you see when, the launch vehicle will at the lift off, that is a very, very crucial period. When at the time of lift off, when jet is impinging on the launch pad, the acoustic load is so high. And there are so many things which we cannot predict. This is a very, very complicated flow field, very complicated system.
Thank you, sir, for answering the questions by our audience. Let's also congratulate Dr. Khan because his daughter, Ms. Ambareen Khan, has recently conferred the PhD. Today she has defended her thesis and she has conferred with the PhD. Congratulations, Dr. Khan. You're a proud father. Thank you once again. Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. Quoted Melody Beatty. I now request Dr. Sharmila Kumari, Vice Principal, PA College of Engineering, to propose a vote of thanks.
Respected dignitaries of the program, dear colleagues, students, ladies and gentlemen. Firstly, let us all congratulate the dedicated team of ISRO for the remarkable achievements in space, science and research. A hearty congratulations to the ISRO team led by ISRO Chairman, Mr. S. Somnath, for the historic launch of Chandrayaan 3. This extraordinary feat highlights the advancement the country has made in space, science and research. This milestone in India's stellar space journey makes every Indian proud. PA College of Engineering hosted the Chandrayaan Mahotsav event under the flagship of IEEE societies, namely Aerospace and Electronic Systems Society, Robotics and Automation Society, and Institutions Innovation Council. As per the invitation of the Indian Space Research Organization of the Ministry of Science and Technology and the All India Council for Technical Education of the Ministry of Education of the Government of India. A good afternoon and warm greetings to all the dignitaries present in this program. I am honored to propose the vote of thanks on this August occasion of Chandrayaan Mahotsav at PA College of Engineering. I profusely thank our honorable chief guest, Mr. Puneet Kumar Mishra, Head Satellite Antenna Characterization, Test and Design Section, UR Satellite Center, Bangalore, for accepting our invitation to inaugurate Chandrayaan Mahotsav event. The inauguration gave us an opportunity to come together as a community and celebrate hope for the future. Sir, thank you for your very insightful address too. Thank you, sir. We have with us an eminent personality, a keynote speaker of the program, our well-wisher, former scientist of DRDO and former principal of PA College of Engineering, Dr. S.A. Khan. Currently, Dr. S.A. Khan sir is working as a professor in the Department of Mechanical Engineering, International Islamic University, Malaysia. So your knowledge, expertise in space and defense technology and inspiring speech reflecting the privileged combination of experience and wisdom that will stay with us forever. Thank you, sir. I request all our faculty members as well as students to make use of this opportunity. So we have got enough information as well as knowledge from the experts, today's guest. So my sincere request to all our students, contribute your to the space technology through your ideas, design and implementation. Thank you. So I take this opportunity to express our gratitude and sincere thanks to our Honorable Managing Trustee, PA Education Trust, Mr. Abdullah Ibrahim, for his wholehearted support to conduct this event. Dr. Ramesh M.K., our beloved principal, meticulously planned this memorable event and led the PACE team. Thank you, sir, for being a great leader. Your support and belief in your team have motivated us to raise the threshold of performance even higher. Sir, I take this opportunity to thank you wholeheartedly for your commendable contributions and unique ideas to take this institution to the greater heights. We are grateful to the distinguished principals, invitees, faculty members, students of various institutions who have accepted our invitation and graced this occasion online as well as offline mode. We are grateful. My deep sense of gratitude to principals of PA Education Trust sister institutions, Dean Student Affairs, PA Education Trust, and Director MBA, Dr. Syed Amin, heads of various departments, esteemed administrative and academic staff members, technical and supporting staff of PACE and PA Education institutions for their wholehearted support and much required guidance in organizing this program. So I greatly appreciate the wonderful work done by the organizing team of this event, led by Professor Ismail Shafi, HOD, Department of Physics, and Coordinator for Scholastic Activities, PA, College of Engineering. Thank you, sir. I thank wholeheartedly Professor Muhammad Zakir B, Assistant Professor, Department of EC, and IEEE Branch Counselor PACE for his sincere efforts to establish various IEEE societies in PACE and encouraging to execute the notable activities under the banner of IEEE. Thank you, sir. I am immensely thankful to Master of Ceremony, Professor Fatima Rehana, Assistant Professor, Department of Computer Science and Engineering, for her efforts towards anchoring of today. My deep sense of appreciation to Mr. Muhammad Shafiq for invoking Almighty God. Finally, I thank the wonderful audience of our dear students for your active participation in this event. Let me conclude vote of thanks with the best wishes to the team ISRO. After success of Chandrayaan 3, so India continues its space journey. Congratulations to our scientists and engineers at ISRO for the successful launch of India's first solar mission, Aditya L1. This is the sunshine moment for India. May Aditya L1 voyage the sun illuminates new frontiers of knowledge. So let us all wish all the best to Aditya L1 spacecraft for its long journey to put into the halo orbit of L1. Still, so again, ISRO has a busy schedule ahead with thrilling future projects. Let us all wish the ISRO team all the best. Thank you, one and all.
Thank you, ma'am. As we conclude this remarkable event celebrating the success of Chandrayaan-3, let this serve as a reminder that as a nation and individual, we have the potential to reach beyond the moon, beyond the space. We have already seen the launch of Aditya L1. We can overcome the challenges and continue to reach new heights in the world of space, science, technology, and exploration. Thank you for being a part of this momentous celebration.